All right, here's our second video in section 4.7. We've been talking about polynomials with several variables, lots of different letters or variables in each one. Remember, we talked about degree when we had a single variable. If they were all x's, we could say that the degree of our polynomial was the highest exponent on our variable. What happens if we have multiple variables? Well, the degree on a multiple variable polynomial is really the total value of all exponents in that term. So for example, if I gave you this term, 5a squared b to the fourth, you notice that there's multiple variables with different exponents. I can still find the degree though by adding those exponents together. So really the degree of this term would be 6, adding the 2 and the 4. Okay? Look at example number 3 and let's practice that. Example number 3 says to identify the degree of each term and the degree of this polynomial. So looking carefully at each term, I can determine the degree of each term by simply adding the exponents together. So on my first term here, if I add the 2 and the 3, I would say that this first term has a degree of 5. My next term, remember there's an invisible 1, would have a degree of 6. That's 1 plus 2 plus 3. My third term would have a degree of 2. The 4y has a degree of 1. A 5x squared has a degree of 2. And now be careful, 7 really has a degree of 0. Remember that the degree is really the highest exponent on the variable. And really there's an invisible x to the 0 power, because remember anything to the 0 power is 1. And so really I would have a 7 times 1, or just a 7. So the degree there is 0. That means the highest degree of this whole entire polynomial would be 6. All right, now let's talk about combining like terms if I have lots of different variables in my polynomial. Remember, like terms have to be the same exact variable with the same exact exponents. They have to look exactly the same in order to be like terms. So looking at this polynomial, I have an x squared and a y in this first term. That means I can only combine that term with other terms that have an x squared and a y. Okay? So looking at this polynomial, I should be able to take the 9x squared y and subtract the 5x squared y because they have the same exact variables with the same exact exponents. I can then combine the x and the y squareds because they are like terms as well. You should end up with a 4x squared y plus a 2xy squared. They look close to being the same, but they're not. They have to be the exact same variable with the exact same exponent to be able to be combined. So that would be my final answer. Or you can write it in a different order. You could write the 2xy squared first and the 4x squared y second if you want to. Just be careful with your signs. They should both still be positive. Let's practice one more here. Look at example number 4. Find all of the like terms in this polynomial and combine them. I noticed that I had terms that have a's and b's in them. I have a 7ab and a 9ab. I combined that into a 6ab. I also noticed that I had ab squareds, so I combined those into a negative 2ab squared. I also have a couple terms that have a cubes in them. 6a cubed minus 11a cubed is really a negative 5a cubed. I have that lonely b term, that's a 1b. And then I have the minus 1 in the back that doesn't have any like terms with it. Since none of my terms have the same exact variable with the same exact exponents, all my like terms have been combined, and that would be my final answer.